Welcome everyone. Let's wait for 5 minutes. Meanwhile, please like the video. If you are new to the channel, please subscribe to my channel. Okay, let's start the live. So, so in the part two today, we started dynamic allocation. So let's see dynamic allocation. Okay, 40 points are there. Let's try to complete today. Uh, Last final two chapters. One is dynamic allocation and file handling in the handwritten notebook. So let us see. So it's one of the most important topics in C because it allows a program to request and release memory while the program is running. So it's not a static allocation. So when we generally write into array of 10, right? So, this 10 can't be changed, can't give more to the array, or we can't make less. So, but we can overcome this problem by using dynamic allocation. Let's see how we can overcome it. So what is the dynamic memory allocation? So normally when we declare a variable in text, the compiler knows that x needs memory for an integer. So compiler knows. Similarly, int array of 10, the compiler knows the size needs memory of 10 integers. But what if the user enters? So what if the user decides the size of the array? So let's say let's say I will take int10. Okay, so scanf %d comma address operator n. So user gives the n value, and I will decide the size of the array. So let's run this one. I will give 5. You can see. Let's print the size of the 0 size of array. You can see right 5. So integer will be 4, right? So let's divide that one also. Size of array of 0. So now it will be normal %d only. You can see right size is 5. So we don't know necessarily the required amount of memory before the program. So dynamic memory allocation allows us to use program give me this much memory while you're running. So it's like we are we don't know the size of the array, so we are telling in compilation time when we don't know, when execution time we are adjusting the memory according to the resource provided during the execution time. So let's see static or automatic allocation versus dynamic allocation. So consider int array of 100. The size is fixed. So you get 100 continuous memory blocks. So you cannot make it to finite elements later. So but with dynamic allocation, so 100 into size of the integer. So you request the memory for 100 integers during execution. Where does dynamically allocated memory come from? So it will be in an area called the heap. So let's see what is heap. Yeah, what is heap? So heap is a large flexible pool of memory used for dynamic memory allocation. So unlike the stack, which automatically allocates instances of local variables, the heap must be manually managed by the programmer. There is nothing but a memory space which can be managed by the programmer. Oh, outside of the stack, it is. So dynamic life cycle. So variables allocated on the heap do not disappear when a function ends. So they remain alive until you explicitly free them. So globally, we'll see this point also, dynamic life cycle. Global accessibility, any part of your program can access heap memory as long as it has pointed to that memory address. It is a global one, so you can, so the scope we can say, if we write here another function, so the same pointer can be used here. So the heap is typically much larger than the stack and primarily limited by a physical computer RAM. So you can say literally whatever the program is used in the RAM plus what is used and what is free in the RAM. So the free is nothing but heap. So access via pointers. You cannot make a heap directly. You must access through the pointers. So let's see why it is accessed through the pointers also next. So let's take this important point. Just to write here. So where does dynamic allocated memory come from? So it will be in it. So generally, our process memory layout will be stack heap initialize data and code a test. So this implementation system based. So there is no need to be this much execute. Some other blocks also may come memory layout. So, but the important idea is that malloc, callalloc, and realloc obtain dynamically allocated storage commonly from the heap. So why do we need pointers? So when malloc is done right, so it it allocates requested number of bytes in a heap, okay, and returns a pointer to the first byte of the allocated. So it's nothing but simply throws the address. You can say so to cache that address, we need a pointer. So that is what we are doing. So generally, up to now we saw pointers catching the another variable address, but now we are catching not variable but directly memory address. So that's why one of the points came here, right? Pointers. So this much no need actually. Yeah, pointers in C. This here interact directly with the hardware. It's like hardware means memory, mainly memory you can say. So, or you can here allocate memory dynamically. So, sorry, this one interact directly with hardware means to play with the registers. So, but allocate memory dynamically means this is what we are talking about. So, we are taking the dynamically allocated memory in the heap address to our pointer. So, for now we only saw it catches only the address of variable, but now we are catching the address of memory. So this is memory and this will catch the memory. So for example, conceptually another addresses 5000 unknown. So values here unknown. Okay, this is the value, not value. Okay, so we need somewhere to store 5000, right? So what does feed us? To take the value 5000 inside the P. So inside the P means pointer. So heap memory. So points to the memory of the heap memory. So therefore pointers are essential for accessing dynamically allocated memory. So we saw why pointers are essential for dynamically allocated memory and why the heap memory should only be allocated through pointers. Okay. So the four main dynamic memory functions. So C provides four important functions: malloc, callalloc, realloc, and free. So they are declared in this library. We should mention if we want to use this standard library.h. So their purposes, that's record memory. These two are in contiguous memory only. So allocate memory and the parallel is allocate memory and initialize it to 0. So the value inside that memory will be 0. So reallocate will be resize the previously allocated memory. So generally if you say here with YouTube 100 blocks, but we want to change to 500 blocks, so then we can use reallocate and free. So as we said in the if, even the function names, the heap memory will not be destroyed or deallocated. So if you want to deallocate, we have to use this free. And let's see function by function. So malloc. So malloc means memory allocation. From memory it took first, and from alloc it takes alloc. Allocation took starting 5-letter words alloc, so it's called malloc. So pointer is called malloc. Number of bytes is the syntax. Okay. So example, int star p is equal to malloc size of the int. So we are only asking uh, the size of an int block give the address to the pointer p. Suppose an integer requires 4 bytes, then malloc requires 4 bytes conceptually. Conceptually, p will point to that 4 bytes. So let's uh, let's write it. So we should first include the library, standard library, as include std lib dot Ritchie. So int meaning let's declare a pointer. So now let's to this pointer let's allocate the memory. So size of int. Let's now see the value of p. Okay, so it will be percentage p comma p. Okay, so let us see. So you can see that this is the address of the heap where we allocated the memory for the p. So let's see size of so size of p will be size of int. So yes, so we don't need to check the size because it will be given 4 bytes only. Now what we can check, let's check the value inside it. So for value, let's dereference operator will use. It's giving me sorry, giving 0 because this compiler may initialize it to 0, but can be a garbage value. So it's a dependent, but you should fix it like dependent. So let's see in another compiler just for confirmation. Take this code. It's giving 0. Let's ask ChatGPT wants to confirm this one. So it is taking time. Let's wait for a minute. So it's still taking so much time. So now let's test it. What is the output here? Let us see what it will give. So this is an undefined behavior. So malloc allocates memory does not actually its the content. So indeterminate. So so indeterminate value it's undefined behavior. So this is what you have to expect. Compiler implementation that is their wish, right? So can be zero or it can be anything. We should not study C with existing compilers. We have to study whatever they wrote, in official C, right? So this is an undefined behavior, we can say. So this is an undefined behavior. Let's say why use size of int. So we can write 4, right? So this is the so standard comparison use 4 bytes, but there is no rule that it will only use 4 bytes. So that's why we are writing size of the int. So compare determine the size by current size of the current implementation. Better, better still, p is equal to malloc size of star p. Why? Because p is int, then size of star p in size of int. So this avoids repeating the type. So we use p. So if it's a character, then it will take character automatically. So size of star p. So p means address, star v means value, right? So that's why we have to write to star p. Now malloc returns white star. So malloc is inbuilt function, right? So we have to know what it returns. So it returns white star. So it is returning white star, but this is an int. So it's automatically like implicit typecast is happening. So no need to worry on that. So white star malloc size t size returns a pointer of type white star is a generic object pointer. So it can be assigned to an object pointer without an explicit cast. So you don't need to write typecasting into integer pointers. So this is a void, so it can be explicit cast or implicit casting. It will happen. So the cache is unnecessary can sometimes create problems. So such as forgetting to include stdl video. So let's see what does malloc actually gives. So we already saw that. Again, let's see once again. So this is extremely important. Malloc gives a pointer to the block of allocated memory of the request set. So it does not give you an integer value. Initially, the contents of memory allocated memory are predetermined. So don't assume the print 0. Instead, rp is equal to 50. So now we initialized it. So we can do. Uh, let's write here. This is a undefined behavior. Okay. So let's do like this. So now the give star is equal to 50. Then we can print value 50. Let's say 50. So complete malloc example. It gave the example here. So malloc will return a white star we said it. It can give null also. So let's see what is null in C. is a null character in C. I mean, null in C is null keyword in C. It's a macro defined in standard library that represents a null pointer constant. So it is used to express that a pointer does not point to any valid memory location. Okay, so it defines that it does not point to any valid memory location. Special reserved memory address that cannot be safely accessed. Okay, so let's take this and add it in our thing. So this is the first time we saw null keyword, right? So it is not a keyword. It is a precursor macro dependent standard library that that represents a null pointer constant. Okay, yes. So let's write before this one. So let's give null here. Let's let's comment it out and check it's from standard library or not. It's crashing. If you can see, uh, print printf I. Yeah, it's printing I. Okay, it's a keyword, I guess. The preprocessor macro. Okay, it is in for standard fields like it's there in input, so that's why it is giving. So let's now check what is the address for the key. Okay, so it is a it will give RP star. Okay, so let's take this and ask ChatGPT. Let's ask is this a undefined behavior or not? Say undefined behavior or not. I think I have to move to new chat. So these are also undefined behaviors. Asking a null pointer, it is does not it does not point to another variable memory, but we are asking to print. So this is a undefined behavior. Let's ask now this one undefined behavior. So this is not a undefined behavior. Null pointer value. So passing the pointer value to printf. So it cannot be dereferenced, but it can be This is a pointer value. So your code output is something as nil. Implementation defined. Okay, so we are getting nil. So let's write this point also. So we'll get address as nil, but pointer value, but it cannot be dereferenced. So now let's write this code. Okay, so let's go to the malloc. So int star p. So p is equal to malloc. We want only the size of star p, right? So integer only we want. So p is equal to null. So when this p will be null means when malloc fails, so then it returns null. So p is equal to null, then we have to return. Sorry, we have to print up memory allocation is failed, and then return the value. So if it is done, let's initialize the value and then printf percentage d that value. So once we have completed this one, we have to free it p. So now deallocates the memory in program, and we have to write p is equal to null. So this point I will tell you later why we have to write it at a compulsory. So you can see right 50. So the process is declare pointer, request memory, check whether memory is allocation succeeded, use the memory, release the memory. Declare the pointer, request the memory, check whether allocation is succeeded. If it is succeeded, use the memory and release the memory. So 5 steps. So why check null? So memory allocation can fail. So this is what we are talking about. 17th line. If p is equal to null, so memory allocation can fail. For example, p is equal to uh, malloc size of may fail to provide the requested memory. So when allocation fails, it returns null. So therefore, p is equal to null. Print of allocation is. So this can happen when heap is out of the memory. So then it gives null. So therefore, it is important to check. Okay. So dynamic allocation of an memory of an array. Sorry. So let's see for the array. So the user enters the number of elements. So this already we saw this one 5. Then we'll be given 5 into 4 20 bytes of space. So you can use it like P0 10, P1 20, P2 30, P3 40, P4 50. Why can a pointer be used like an array? Because P of I is defined in the terms of pointer with P plus I star. So this will be I means the will be scale factor. So I into size of the I is the integer, then it will be size of the int. So it will be pointer arithmetic. So it will go to the memory address. So we'll be accessing the values. So therefore, and we also saw in arrays and pointers also like they are same value. Like they are almost same. So you can write p of 0 in terms of like this, and you can write this pointer in arrays like this. So it's bidirectional. Okay. So p of 3. So this is what we saw. So complete dynamic array example. So in 10 number of elements we have to give, and then allocation will happen. So but before this we saw So int n scanf percentage d comma and then int array n array of 0 is equal to 0. Let's print up percentage d size of the array divided by size of 0. So array 0 is a variable, so it will be compiler will see it's an integer, so it will take size of, which already saw for the pointer star pointer, right? I have to put size of star pointer instead of size of int. So let's run this one. My bad. So let's give 5. The answer is 5. Let's ask ChatGPT how the memory is allocated in this case. Variable length array automatic storage with automatic store duration. The equivalent storage is obtained from stack when execution reaches here. So it is not dynamically allocated memory like array. So VLA variable length array, what, right? Variable length array size determined at runtime, size determined at runtime. Automatic storage, automatic typical stack is the heap. Is the difference between them? So automatically release must be used free. So size of the given array. So size of the why is this work? So it's optional in C++ and data. Before that, it is not there. Let's use malloc on it. So you have to write int star arr is equal to malloc is n into size of int, right? Size of star array, which is the first element. So let's now check if array is equal to null. Printf memory allocation is failed, and then we'll write return 1. If it is not, then let's do the scanf and initialize the value. So I will assume so scanf percentage d. Here we have to give reference. That's what they are doing, and take the same thing and print it. Print up this two new line. So now we will run. So we'll write 5. So now we gave the 5, so it is here. So it got success. That's why it didn't print a memory allocation field. So now write 0, 1, 2, 3, 4. Oh, sorry, the address is given. That's second write 5. And is the 5 here. 0, 1, 2, 3, 4. Again, you can see 0, 1, 2, 3, 4 is printed. So now we have to free the memory, right? So let's free the memory. You can see right, initialize an array pointer, but use like an array. So these are both can be what we can say. I, what we can say both can be written. So it's bidirectional. Okay, let us see. Let's see now. Call alert new function. So it is a contiguous allocation. Both are contiguous allocation, but this will initialize by allocated bytes to 0. So let us see. It is also returns pointer only. So the syntax is call allow number of elements you have to write, and then you have to write the size of each element. So size of each element, so size of the pointer value, the number of elements will be giving in scanner. So let's see the example. So here pointer p is there, teacher pointer, and we wrote call allow. So 5 of the size and size of p. So 5 times the size it is given. So this is nothing but an array. So the important difference is call allow indicates all bytes to 0. For ordinary integer character code driven, this results in 0 values for those objects in normal. Yes, the C standards avoiding is technically about zeroing the allocated weight, so don't generalize it all types become a semantic zero without the qualification. So let's for this only it is give 0. So let us ask in another case an example. Um, so this is a double pointer. So one pointer it points to the variable to memory of the memory of the address, and that points to address of the memory. So you can say P points to address, RP points to another address. Okay, so this is like RP if you take int, so P points to variable, and star P is X value. So we say double star P. So let's now edit this one. Okay, let's say star Z. Okay. So this double star Z. So double star Z. Let's say Z points to Z points to I got confused here. Let me think for a while. Give me some time. So that to start this, so that points to a variable, so address of a variable. So what it can be address of a variable means star p, star p. Okay, let's uh, int double pointer. So generally pointer means pointer points to address of a variable. So we can say double star p gives value. So let's equal to another pointer z. So this z contains the value of x. So double star p gives the value. So percentage p gives z. So z is x address. So p. Okay, now I got it. So p is address of pointer, not a variable. Uh, I mean variable only, but pointer variable. So star p means value of pointer. Value of pointer p is address of pointer. So it is address of z. So sorry, this one is star p means address of x, so which is z pointer. So double star p means value of x. So double pointer means uh, it shows the address of the pointer. You can see it. Let us see double pointer also. Into double pointer p. Let's say that int x is equal to 50. Now let's say into z is equal to x. Okay, comparand x. So now let's equate is equal to let's put here Yeah, now we are getting address of Z. So let's print the address of Z also. Yeah, I can see right. Address of Z we are getting. Sorry, that is address of X. This percentage P and X. So let's see. Yeah, we are getting address of X only. This is correct. So let's ask what is double pointer. The formal definition: variable that shows the memory address of another pointer. So if I write double P and print here address of Z, oh, this is the value, right? So how to get the address? Somehow I can initialize like this, right? RP is here. So Z to printf is we are getting. Okay, we did it. Uh, okay, like this we have to write. Sorry, my bad. So let me see this one. I know we are deviating, but this double pointer understanding was important. Okay, I have to write here. So let's see. Uh, let's see first what is the address of x. Okay, so this is the address of x. So now, so z will hold the value of address of x. So how to write this one? Percentage d we can't hold, right? Percentage p comma z we have to do. Yeah, so z contains the value, right, of x. Star z contains the value of x. So z contains the address of x. So this is how. So now we want to know address of this pointer. So somewhere z also will have a pointer. I mean address in memory, right? Let's decode that one also. So let's write the address of x is the value, the address value stored by z is the address of z is. So this is the address of z and this is the value stored by z. Now let us see printf percentage. So the value stored by double pointer p. Or p. Let us see. So it holds the address of another pointer. So if you want address, then you have to write single star p. Again, again C. Yeah, so p holds the address of z. So star p holds the so it goes into this address. So z, so it gives this value. Address stored by z value. So that value is this one star p. We put another star p, then it will be address of p, sorry, the value of x, which is 50. Yeah, it's 50. So if you want address of double pointer, then you have to put like this. It gives some value. Now why it is matching with this one? Oh, I think like this I have to do, right? Yeah, this one. So these are the same. Okay, this one I have to do. Yeah, now it is correct. P is a double pointer, star P is a single pointer, star P is a value. So this is how we have to remember this one. Sorry for my confusion. So now let us see. This is the address of. So we want to know what pointer P is to. So it should be. Uh, so so pointer P double pointer shows Z pointer's address, right? Then we have to write like this. Sorry, like this. Yes. So P contains the pointer of address, the value of pointer Z. So star P means it is address of X. So another star means value of X. There is nothing but 50. 2 into 16 3 is the 48. So 50 is this value. So again P is the double pointer. So it should contain the Z value. So it will be Z value. If you want P address, then you have to write ampersand P. Then it gives another value. So this is how the double pointer is. So now let's go back. The best example is but so does not vary. Same pointer issue is there here. Semantic value is not give, but every speech is pointer will be not guaranteed by C standard. You have to remember this one. So zeros the bytes. Okay, what do you mean by zeros the bytes? Oh, so 8 bits, right? So 1 byte filled with 0 looks like this. Okay. Yeah, I got it. What do you mean? 0. So that's what here explained. So let's write an example. So let's write here call alloc. So contiguous plus allocation. So that's why they gave the call alloc. So first we write size, so let's be n, and then we have to write element size, number of elements and the size of the each. Size of array star array. So now let's write 5, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So that is what alloc, malloc and call alloc. So difference you will see. So the initial contents are indeterminate and these are initialized to 0. So if I remove this point, right, now if I run, let's say I will give 3 values. You can see 0, 1, 2, 0, 0, 0 is initialized. So, but we can guarantee that bytes are allocated bytes are initialized to 0. So for int it will be 0, character will be null, for float it will be 0. Takes one main size argument, memory is not initialized. Often when you will immediately initialize the data, takes number plus size. So two parameters, here one argument, here two arguments, allocated bytes is 0. Convenient when you want to 0 initialize the storage. So realloc use pointer array with 5 elements. So when you restore, you need 10 integers. You could request a new block, but C provides a realloc. So you can malloc it and free it, and then you can use realloc, but it's better to use realloc, changes the size of existing function allocation. So let us now see. Just give me a minute. Now let us what happens during the reallocation. So originally it will be 10, 20, then you request a larger block. So realloc will be 10 into size of 5. So we give 5, here it will be 10 elements, so it can expand in place. So for the 10 elements it will expand, so it will give new memory address. So we'll check that one also. It needs to move, so new block it will be given. So the old block will be released as part of successful realloc operation. That's why you must be careful with the pointer. This is what it means. So here it is showing the old block is released as part of a successful realloc operation. So don't normally do p equal realloc p comma new size without considering failed view. So if it is failed, it will give null. So p is failed here. So p will be immediately go to null. So old block also happened and memory leak. So because old block is not vanished, it is still there. If it is returning null. So first use a temporary, and then if it is there not there, then use this temp pointer. So we completed up to realloc. Let's take 15 minutes break here. Okay, let's continue the session. So let's take this real script code. Okay, enter star p into n nf percentage d comma and then now, now do the allocation. Is equal to malloc of n into star into size of star p. Let's give like this the values equal to I. Okay, now let's print also. So now I printed the value. Now I want to change the size of the array. That's what they're doing it. Take the new pointer temp. Again, forgot to write here. P equal to null. Printf memory allocation is filled and return. So why am I writing this? So it's filled, right? So you should not execute this line. So that's why we are returning the function. Now we are reallocating it. So that is equal to I want 10 elements, not 5. So here is equal to 10. Okay, or we call scan of 10 for different size. Real star and see the syntax. So we have to give here variable right p comma we have to into real star p. So now let's same thing. print the values. Okay, so first one will be giving the value for, so you can see 0, 1, 2, 3, 4. You can see 10, 0, 1, 2, 3, 4, 5, 6, 7. What is this 2, 6, 1, 5? Oh, sorry, I didn't give the value right. Temp is equal to null. Return 1. Enter. It got habituated. Memory allocation got failed. Memory allocation got failed. So now let us look into how we can write t is equal to 10. So now give size of n is 5. We'll say 0, 1, 2, 3, 5. Now we give 10 0 to 9. So that's what the allocation is. So let's now print this starting address of the p also. So at here, right, print out starting address of pointer p percentage p. Here, what should be the here? Yeah, p should be there. We don't want the address of p, but we want what it malloc could throw to the p. Right? I will give. So this is the address. Now we will give 100. Sorry, not 100. 10 will give. You can see the address has been changed. Okay, starting address has been changed. Okay, so this is the real up. Now we will see free. So it's nothing but deallocate the memory which we have given. So once it is used. So no, the answer is no. So that's where when we are reallocation over, so we are writing free. So you have to. So free means from heap the memory is dissolved, but pointer still holds that memory address. This is the problem. So, does not automatically change p to null. So indeterminate value for practical purposes of these as a pointer to that read object. So it is commonly called a dangling pointer. So this is called a dangling pointer. So it points to a memory location that has already been deallocated, read or gone out of scope. So this we will write. So here we given right. So now let's write free the p and p is equal to null. So now deallocation happened here. So and p value is given null. So we can ask like why designer into the p as null, because there can be two pointers pointing to the same memory address, right? So but if we say free p, so still dangling pointers exist. So this is wrong. After once you freeing, you should not dereference it because the value is gone. So it causes a undefined behavior. You can ask the address, it will print, but not the value. So for example, let me take this one. Okay, let's write 5. Okay, and I will write 10 here. So if you see a p still points to the same address. It is giving only 10. Okay, this one I have to write this part. New. Now we can see that these are two same. It's still pointing even after the freeze happened. So now if I put p is equal to null, and it prints the nil. Yeah, you can see right, it is printing nil, but you can't dereference like now. Let me remove this null. So star p means we should get p points to some address, right? So in that value you have to fix. So but that value is indeterminate value. So because we dissolved it. So what happens? This is undefined behavior. You can see right, it's giving some other stuff. Just p means hexadecimal it is percentage d. You can say 5, 10. It's giving some undefined behavior. Compilers are giving some values, but this is undefined behavior. So what is a memory leak? So we saw dangling pointers. So it is nothing but till the pointer points to the memory location, even that memory location has been delocated and feed are gone out of the scope. So what is memory leak means? So here int we are doing first we are taking 100 bytes, right, and then 200. So what happened to the first memory location? So we lost the pointer address you see here. So you cannot free it anymore. So the memory is not leak. So the memory leak. Correct way just print or use real. So four important memory problems. One is memory leak. You can see we lost the pointer address which points to the first 100 and dangling pointers. So after freeing the memory location, the P still points to that memory, but we should not access the value. So this is called dangling pointer double free. Freeing the same location type. This is also an undefined period. So once it is done, uh, the first time it is memory is dissolved, reallocated, but what about the second time? What we are doing? So this then we don't know what happens. So this is an undefined behavior. So double free and invalid out of bound access. So here only we give 5, but P of 5 is in bounded, so it is not will happen. So let us see that one also. Let's print percentage d array P of 10. Okay, is the next value. Let's take 5, that will give 10. You can see it is again memory inbound access. So this we can't do. So that's so this is also an undefined behavior. So now let's see. These are 4 undefined behaviors: memory leak, dangling pointers, double free, and invalid out of bounds access. So dynamic allocation structures. So structures we'll see. Revise one's structure. Uh, Memories. These are memories. So student is the tag and RP. So is a structure pointer. So we are allocating some space. So now this P holds the address of the heap. Now we can change the role and marks of this address. P role P marks initially free P. So dynamically allocating an array of structures. Dynamically allocating. Now we are seeing dynamically. So I think we did here, right? Thing. So 100 into size of P. So now we have place under structures. It's like arraying the structure. So you can use like this or like this. The same like int star P only. So dynamic memory and linked lists. So this is the linked list one. So you can say right node this pointer is there. So it so P is the starting. So this one holds the next node address. So like this P points to this memory heap. Okay, so we can create another node 2010, and now we can give P next is equal to Q. So now it will contains the address of this next linked list. So this is the foundation of linked list. That means in C++ also we will have pointers. Yes, we have in C++ also we have the pointers. Can I see pointers? You must use it. Okay, so we have to write implicit conversion. Sorry, explicit casting we have to use. Okay, got it. So let's write explicit only. Try to risk. Let's remove this. So it will be memory, it will be null PTR. So distinct object oriented. So side by side memory to fully supported intersect strict explicit white shell convention. So null macro, null pointer keyword. Okay, so this is somewhat I'm seeing. This is a new point for me. White star conversion. So malloc versus normal array. So I think in Python no concept of pointers. Yeah, we saw so many memory leaks. So the automatic garbage collector. Okay, okay, so let's go to the 30th point. Malloc was normal array. Normal array is defined. Amount of storage is defined at runtime. This was stored in stack. This was stored in heap. As the dynamic at that point also in a heap. So that stack. So this is useful when n equal to user input. So what does the dynamic memory mean? Memory created at runtime. So this memory allocation process obtaining and releasing storage program during program execution. So but decision is not mainly runtime as competence. These storage duration rules are more precious. So dynamic allocation storage has one lifetime controlled by location delocation function. This one is created at runtime for sure. Memory is allocated at so important memory doesn't create a variable. Yeah, it doesn't create a variable towards the address of the allocated space. Returns a pointer variable called p. So that's incorrect. P is a pointer variable obtained an allocated region of storage. Conceptual like this. So size of and dynamic allocation. So you use frequently say malloc and star size of star p. Suppose in star size of star p means size of int. So malloc is m star size of star p means allocates n of n objects pointed to by p. N objects of the type pointed to by p. So this is a very good pattern. So we'll not is need to float data type here. We'll write the value here. So it will implicitly convert. So why malloc can star size of int can be dangerous. So for normal small examples, malloc can star size of int is fine, but when calculating size from arbitrary n, integer multiplication overflow before the allocation occurs. So sufficiently large could wrap around the integer type user for n. So for robust programs, size calculation should be designed carefully and validated. So this is why you cannot be represented the type being used for the calculation. Integer or so this is the starting. You downstage will come, so that's why they're telling to use this one. So that is the main use, nothing. So this will not prevent overflow. Just the way type size of type double and int is there, right? So that's why. So analog zero. So you're telling to give zeros. This is a undefined behavior again. So sorry, this is implementation depend behavior for zero size adaptation. So it depends. It will give null or that must not be dereferenced. So that's good. Implementation behavior means but don't reference it. This is the undefined behavior. So it's like null only. When the pointer is pointer, then pointer is dereference it. So like that. So free of knowledge is does nothing. Wait for install freeze to null, free null, nothing will happen. So dynamic allocation life cycle. So allocate memory, read through the pointers, create the memory release. That's what happening. The most important example, malloc fail. This is what we saw, right? So quick comparison. Allocate uh, biggest storage. Initialize memory, no is 0 bytes. So resize new portion. Just size non-failure. So what I revise those points are only coming. So that's all about this one. Dynamic allocation in C. Uh, so I think learning 2 or 3 more languages it confuses I guess between C and C++. Okay, now let's see file handling in C. So the last chapter, chapter 27, file handling in C. So let me read my notebook and later, and then we will discuss it here. Okay. So it gave me 88 points. So I don't want to go through once and then repeat these points. So I will be reading and saying. Uh, so let's begin with what is file handling. Is a process of creating, opening, reading, writing, modifying, and closing files. So we'll create the files, open the files, read the files, write the files, modify the files, and closing the files. Also using C program. So uh, normally variable stores data temporarily in. So when the program terminates, the value X is lost. A file allows to be stored permanently in second storage such as SSD or hard disk. So for this index declaration, so it will be stored in X and then it will lost. But file is stored in SSD, we have to bring to the RAM. So file handling function, files and secondary storage, write data, read data, appended. So why do you need files? So after 95 and the program runs, this is lost. So, but you want to store this mark, so you will be creating this .txt file, text file, and you will store it in SSD permanently. So temporary persistent execution during program execution exists independently of program execution. So limited by available memory can store much larger amounts of data. Data disappears when the program ends. Data remains after program. So that is the difference. So types of files in C, text files and binary files. So text files. So okay, only we are dealing with the text files and binary files. So text files store data in form that can generally be interpreted as characters. Okay, nothing but characters only. So hello 195.5. So text editor means okay .txt, csv.txt. Okay, csv file also there. Binary file means it stores the data in bytes. Not requirement to represent as human readable text. So it doesn't mean human readable. We can will be storing zeros and ones. So for example, I need to make any 4 byte. So binary version can return directly to a binary file. So binary files are commonly used when storing large amounts of structured data, resulting binary representation efficiency. Simple. So this is the example dot fields dot bin dot bmp files. Text files is string and binary files is numbers. So binary file can number structures, characters, etc. So the file type. So C provides type called file. Uh, it is declared in standard input and output as chatter file. So a file is general access to file pointer. Again, pointer. So pointer points to the file object. So file will be bringing from SSD to RAM, right? So in RAM it will be stored. So we'll be using the pointer which points to the file, and then the pointer file. So instead C library is refers to open stream associated with the file. So display operating system C library stream file object. It points to the file object. So fopen, fprintf, fscanf, fgetc, fputc, we saw fgets, putc, fread, fwrite, fclose. How many 1, 2, 3, 4, 5, 6, 7. Open, we will open the file. Printf, we will see. Scanf, we will see. Fgetc, get, putc, readc, read, write, close, we will see. Close means closing the file. Right there, 8 points are there. Opening a file. So fopen. So syntax will be file star open. File name we have to give, and constant character mode. Let's say the mode means reading, opening, writing, or appending. We have to tell. So file star fp. This is the file pointer. This points to the file object. open stream associated with the okay. So opening mode. So it's successfully opened. If it fails, it returns null. Okay. So at least one print file could not be opened. So this is how we write. Let's see if it works here or not. No such file as a directory. So let's create one. Let's write data.txt. Okay. And let's write cs blueprint. Now let's run. Yeah. Now it is not showing error. So this is another inbuilt function. Let's rename it. So data to we run now. It is showing no such page. So I don't know what is this one. I don't want to go that much depth actually. So mode you will see R means read, W means write, A means append, R plus means read plus write, so W plus means write plus read, so A plus means append plus read, A plus means append plus read. So read means only we can read, write means we can write, append means we can add the information. So already some data is there, so we can add at last. So RB, WB, AB, RB plus WB plus AB plus just same, but you have to write B for binary. So file should already exist. If it doesn't exist, returns null. So contents are not right. We can use this one actually. No writing. Don't know P error is somewhat, but I don't want to go that much deep into the file handling. So W mode, you can write it. If does not exist, it creates a file. Already exists, it just discard and truncate it. So this is extremely important. Suppose data already has hello world. Now if you open it and then close it, it will be data will be truncated. So no data comes. So let's write it here instead of W R. I will put W. Okay, so let's rename. Now we can see data is vanished. Second address CS. Okay. Now we'll run. Data is vanished. So that is writes do. Sorry, I'm reading this adjective method. So a mode append. So if we write A after allow, if we print of means it will print into the file. So world will be added. So existing data is not erased. R plus append plus read. Sorry, read and write. So files must already exist. Existing contents are preserved. The initial file position is at the beginning. So what does it mean? So let's write this one. First we'll append it. So I'll write to CS. Okay. Now I'll write here append. I'll write F to printf function, and then the p pointer I should mention p file pointer, and then I have to use the blueprints here. So now let's run. Yeah, you can see right, see blueprints. If you want, you can use space. So now it is giving blueprints again adding here. So now let's see Arclist. So Arclist is reading and writing it. So but as read, we know when you write a file should exist. If not, it will be error. But in write, we give W. If it is not there, it will create a new file. So file must already exist. So if it is not, it will give error. So let's try that one. Let's put the error to the text. The R plus, you can see right, it is giving error. The initial file position is at the beginning, but the file contents are present. Let's see what does it mean. So let me give this one. Saying that yes only. Now let's run. Now let us see the value. Okay, but it is overrated, right? So let's say now we don't add this one. Now still if I run, blueprint should be there. So this is what it means. So preserved means so when we open the right, we write W. Even if I don't write anything, this will be truncated. But in case of R plus, even I don't write anything into the file, so it is still preserved. So that is what they're telling. But the initial file version is at the beginning. So for example, if B rate, so I will be writing only one letter C. So when I run, you can see right, B is replacing with C. So this is how it will be replacing. So once it is out of that hash data, it will be going. So that is what R plus mode means here. So W plus, so open for both reading and writing. That's what we learn. Yeah, right plus read again. Let's see the difference. Okay, this is the difference. If the file exists, truncate it. Existing content destroyed. Okay. So, but what is the difference? So, right and this one are both are same, right? So, what it can give this? So, right means truncating. Same thing happening. If file doesn't exist, let's ask. So, plus we wrote and then we rewind. So, in the right we can't read, but W can't read, but W plus can. Yeah, this is the difference between them. I hope that gives this explanation a down. So it means append plus reading. So append and then we can write. That's what it. Again, we don't exist. It will create it. Let's see. For append also, it is created. So same, but we can read here. Okay, now it is the difference. So read, write, create the option. No, no. R plus also no. So, but we can write it. So we can see here, right? Read is not happening up here, but it is happening here. Create is almost the same. Read, write happen plus add the other operation. Read plus write plus read, happen plus. So now let's see the test and benchmarks. Just adding the first scene. So this is read mode only. So after finishing the file, you have to close it. It will be close FP index into close file star stream. So it didn't seem open also we saw right. What is the open syntax? It's a file star open and constant care file name and constant care mode. Here it will be int f close file star string. Okay, so file star f is equal to f open. So if f is equal to null, return one. So which means it got failed. Sorry, opening of the file failed. Not close the file close the file is an important one. So release resources are shared with the stream. So it is nothing but if you want to after closing file the still you can write your own code right to deal with some other things. So it creates a free in the memory. So ensure buffer output is handled properly. Use of that stream. So therefore, every successful open file should normally be closed. Basic file and declare file, open the file, write something, open succeed or not, and close the file. So that's what happened here. Check this one. So file stop P, please will have open. You open the file. If it is not open, you're printing that, and you're writing into the file printer. Let's see. Yeah, hello world is the right mode, right? So that's why it truncated and whole thing went dead. So writing to a file. So this is another important function. So for this we use for character oriented it will be f put c, string oriented f puts so as so putting into the file. So either we can writing to a file means putting into a file. So we use that put formatted printf. So block boundary of write. Okay, let's see. F puts rate one character comma string. This is how the syntax. So character and the stream here. Let's see what is the stream. What is the stream in Thailand? So to transfer data into your program, so temporary channel or logical conduit managed by C standard library to transfer data into your program's memory. Okay. So from file to program memory. So let's don't do let's say in the surface level only. So character the string. So if you put character like this, right? So take this one. You have to write put p. Write a character name, character only. So write it in the file point. So now let's see. So sorry, single quotation. Now let's run. It should be it is here. So like that, if you continue writing, say, let's you take example from I. If you want to write I into the file, you have to write put C, then write run. It will be giving us I. So F puts write a string. So string and string. So double quotation you have to write. So that's all that is important. So it does not put slash n. So if you want to write, then you have to write like this. So printf formatted output we already saw. FP file pointer, then we'll be giving a string and then we'll be giving the variable. But we already give this one. But we can this is the optional argument. So printf standard input. So yes. So this is important. Printf file pointer, then format specifier, and then variables, list of variables. So, but I think only one. Uh, let's see this one. Okay, so let's open the file. File star is equal to f data dot to txt. Let's put right now. It will open anyway. File this is called file. File star only, right? It's giving unknown type. Error type name unknown. So this is how we open, right? Dot let's put the data.txt file. Now let's run. Why it is giving error? Mm, okay, calculator is fine. Okay. Sorry for this one. So let's see. This is can't be reading one sentence. Let's see that one also. Come on, marks. I think it is no, I guess. It can take only one argument. So it, yeah, two. Yeah. So it's a good news. So printf is like printf only, but you have to wait 5 point. So writing the file, so there are several important functions. Puts the puts printf write. So this is for but afraid we didn't see right. So so we will see. Let's see write one character. I think we saw this one. Printf is over. So now let's see reading from a file. To get C gets scan up. So exactly where read one character. So it will be we have to take like this. From file it is coming and we have to print. So it is taking int here because subject C needs to represent every possible ancient character value plus value EOF. So therefore it returns integer. Okay. Subject C returns integer, not character. EOF means end of the file. It is a given special negative integer value defined by implementation. So you can see like this. So Putkar is also like we can print it. So this reads characters until the end of the string. So not a character is stored inside the file. It's a special character like in string we use null character, right? Like that we can say. So reading an entire file character by character. So like this you can take. Let's take this. That's one. I can see it. Putkar is nothing but a printf only. But it will have difference between printf and Putkar. Let's not go into deep. So f get c returns integer, not character, because EOF is an integer. It's a special keyword which contains negative value. So reading an enter file character by character, we saw this one. Gets, so gets is buffer size string. So for puts we saw uh, stream comma file pointer. Now it will be buffer comma size comma string. So puts what we saw. F puts we saw string and stream. So f gets is buffer size string. So it attempts to read a line of input into string subject to the specified size and availability of a. Let's see what does it mean. So until a new line or a so it will be reading line by line, not character by character. So if it gets string, so this is a buffer. It will take up to 100 and then it will print. So like this we can say. Scanf formatted input from a file. So fp comma percentage and x. So it will be also taking values from file. So exactly scanf how it is there like that only. So value will be pushed into the A, B, C. So now values will be A, B, and C. File has 10, 20, 30. So file pointer. So printf means standards output. Writes to the stream represented by FP. So scanf is standard input and it is read from the file stream. So standard streams F automatically provides three standard streams. Standout and stand error. Okay, so input is generally keyboard, output is terminal and screen, and error is also you can show error in terminal and screen on the bit. So relationship with the file functions. Uh, so printf can be thought of writing to standout, and scanf can be written stand in. So therefore, so these are relationships. Okay, f gets right. So it will be percentages. So I think I will stop the uh, live now. I think I'm just I'm very eager to complete today the file handling, but I'm not even reading the code also here. So I think I have to take proper 3, 4 hours, 6 hours time. I have to complete. So tomorrow I will be sitting only this until I complete everything in perfectly. So tomorrow we'll be going through each line by line and we will be reading it. Thank you very much. Up to here you came in, so if you loved the live session, so please like the video and subscribe to my channel.